Okay, we're here at section 5-4, exercises 17 through 24. And we're factoring, just factoring all different kinds and mixed up in the method. So here's our little map that will help us to remember where we're headed with which method. Number 17, when it says factor the following, first of all, greatest common factor. Is there a greatest common factor? 8, 63, and 8. Certainly those 8s are tempting, but this is 7 times 9. 9 only has 3's in it, so nope, there's no greatest common factor. So we need 3 terms. Leading coefficient is not equal to 1. It's an 8. And is it a perfect square? Can we get around to doing a real big ugly one? Nope. 8s are not perfect squares. So we must do the AC method. A times C is a negative 64. Now we got to find out what adds to a negative 63. So 1 and 64, 2 and 32, 3, 4 and 16, 5, 6, 7, 8, and 8. And you guys probably saw it at the very beginning. Yeah, a negative 64 and a plus 1. That is exactly what we need to split that up. So let's split that guy up, and we now have 8x squared plus 1x minus 64x minus 8. Good, good. And then what? Well, you see this arrow, the AC method, when you split up b, always gives you 4 terms. So we are now back to grouping. So let's chop this guy in half and group the first binomial together. And we have 8x squared plus x. We can take out an x. And we're left with 8x plus 1. All right, let's use that different colors. Every time we use grouping, that's really good to do, just so we can kind of see what's going on. 8x plus 1. And then in the second half, what can we take out? We can take out a minus sign. And then we've got to take out something that will go into 64 and 8. It looks like 8. Yes, indeed. And that'll leave us a positive 8x and a positive 1. That's good to have that. And oh, now you can see it. The purple there is 8x plus 1. And we take out the x minus 8. As a reminder, when you're doing the AC method, some people worry about not getting the x and the 64x in the right order. Like, what would happen if I did minus 64x plus x? Well, then the x minus 8 would have been in the purple, and the 8x here and the plus 1 there. And you still would have gotten the exact same thing. And since you can switch these by the commutative property of multiplication, it is all the exact same answer. Good. Number 18. All right. Let's do the greatest common factor first. Can we pull out a greatest common factor? It looks like we pull out a 2. This just looks kind of weird. Let's write it this way first. Okay. Now, descending order, that kind of just looks nicer to me. Take out a 2 and an m, and we're left with 3m minus 7. And that's it. We wouldn't have a difference of squares here. We can't go any further on anything. So just pulled out the greatest common factor. Great. Number 19. Is there a greatest common factor between x to the 4th minus 7x squared plus 12? No, there is not. How many terms does it have? 3. Leading coefficient is equal to 1. So this is going to be a quick one here with x. Ooh, it's going to have an x squared in both places. So, and we got 12 over here. What times is to 12? A 1 and a 12, 2 and a 6, 3 and a 4, and adds to a negative 7. Now, if this is a positive 12, these have to be the same sign, so we better have a negative 3 and a negative 4. Yeah, there we go. Now, each one of the factors, since it has an x squared, could factor. So let's double check. This one has 2 terms. Difference of... 3 is not a perfect square, but this is. X squared is a perfect square, and 4 is a perfect square. So this term right here is a difference of squares. So this goes out to x minus 2, x plus 2. And then this guy that can't go any further, it does have a subtraction sign, but 3 is not a perfect square. So that's our end result for number 19. Number 20. Can we pull out a greatest common factor? We need to remember to say that every single time. A 3 could come out. Nope, these two aren't sharing anything. They're sharing a y, but that guy doesn't have a y. So no number, no x in this guy, no y in this guy, so no common term at all. So now we look how many terms, 1, 2, 3, 4. 4 means we're grouping. Chop this guy in half, and what can we pull out of the front? Oh, a 12 and a 28. We could pull a 2, could pull anything larger, a 4. Yeah, 4 and an x, and we're left with 3x plus 7y. Ooh, let's use that other color. We're using grouping right now. Let's go ahead and throw in another color here. 4x, 3x plus 7y. Good. And then over here, we can pull out that minus sign. We have to pull out that minus sign. And if you'd like to see it really obviously, put a 1 there, even though pulling out 1 really isn't pulling out anything, but we are pulling out the minus sign. So we get a positive 3x. Oh, just kidding. I missed something. There is a y in both places, so we're actually pulling out a minus y. That's good to know right there. And so when we pull out the minus y, we have a positive 3x and a, what do we have here? A positive 3x and a positive 7y. Good, we got the same thing, excellent. So now we can pull out that 3x plus the 7y way out front like that. And we're left with the 4x minus the y right there. Excellent. Okay, number 21. Negative 3m to the fourth plus 9m cubed plus 12m squared. It looks like a 3 in everything, and certainly we can take out the negative. We'll make it nice. How many m's could we take out? This one has a maximum of 2. So we're left with m squared minus 3m minus 4. All right, so we pulled out the greatest common factor. What is left has 1, 2, 3 terms. Leading coefficient is equal to 1, and so this guy is going to be a nice quick one. We have to find things that times to a negative 4 and add to negative 3. That's 1 and 4, 2 and 2, and it looks like a negative 4 and a plus 1. That's our magic pair. M plus 1, m minus 4, and then the common factors out here in front. And there is our polynomial completely factored. Excellent. Number 22. 6xy minus 3x plus 2y plus 1. Is there a greatest common factor? No, this guy's a 1. Nothing else will go into that. This guy doesn't have a y. That guy doesn't have an x. Yep, nothing going there. So no greatest common factor. There's 1, 2, 3, 4 terms. So we are grouping. Let's chop that in half. Look at the first half of it. We can pull out a 3x. 3x, and what are we left with there? We're left with 2y minus 1. All right, and on the other half, we got plus, and there's nothing really there. There's a 2y minus a 1. Well, you can see that if you pull out the 2y minus 1, you get 2y minus 1 here, and then you're left with the 3x plus, and there has to be a 1 here. When you divide that off, that's a 1. And if you'd like to put that there to be more explicit so you can kind of see what's going on, that's fine. And if you don't put the plus 1, that's fine. It still is true. Good. All right, number 23, x squared minus 10x plus 9. Is there a greatest common factor? No. So now we're going to say how many terms? 2, 3, or 4? 1, 2, 3 terms. So leading coefficient is equal to a 1. And so this will be a quick one. What times is to 9 and adds to a negative 10? That's either a 1 and a 9 or a 3 and a 3. And this is a negative 10. So negative 1 times negative 9 does indeed times positive 9 and adds to negative 10, so x minus 1, x minus 9. Now you might be tempted to try a difference of squares here, but you'll notice the first term is just an x. So these can't go any further. You're down to an x minus 1, x minus 9. Fantastic. All right. The last one then. Number 24. 21z squared plus 7z cubed plus 14z. Let's put this in descending order just so we can see it a little bit better. Plus 21z squared plus 14z. Good. Looks like there is a common term. Looks like these are all multiples of 7. 7 times 1, 7 times 3, 7 times 2. So we can pull out a 7 and a z, and we're left with z squared plus 3z plus 2. Okay, greatest common factor, done. Now with what's left, there are 3 terms, 1, 2, 3 terms, and leading coefficient of these is a 1, and so this is going to be quick if it works. Let's double check. Times to a 2, could be a 1 and a 2. Does that add to, times to 2, 1 times 2. Does that add to a 3? Yes, indeed. So it's z plus 1, z plus 2. And then this guy just floats out here in front. Excellent.